All right, so 3-1 here, we're looking at what a conic section is today, and then we'll look at the first type of conic section, which is a circle. All right, so let's click here. Basically, this whole unit, we're studying what we call analytical geometry. These are geometric problems that you're solving by algebraic or analytical methods, okay? There are 4 different types of conic sections that we're going to look at. And basically, you get a conic from the intersection between a set of 2 cones that share a vertex. We call it a double napped cone, and a plane. Okay, so here's the double napped cone. And we have, if the plane is parallel to the base of either half of the cone, then you're going to get the intersection to be a circle, okay? If you change the angle of the plane so it is no longer parallel to the base, then you're going to get the ellipse. An ellipse is like an oval, okay? If you change the angle even more to where now you're intersecting the cone and the base of the cone, then you're going to get a parabola. And if you increase that angle so much that now you're intersecting both sides of the double napped cone, then you're going to get what's called a hyperbola. Let's illustrate this here. All right, so purple's the double napped cone. All right, and then the green region's your plane. Over on the right-hand side, you see this is like the overhead view. If you're looking down from above the cone, that's the intersection between the cone and the plane. So notice right now I have it so that the angle of the plane is set to 0 degrees, which means it's parallel to the base of the 2 cones, okay? I'm getting a circle here. It doesn't matter if I move this up or down, okay? I'm still having the intersection between the 2 be a circle. It's just the size of the circle increases or decreases, right? Okay, now notice if I start to increase the angle to where we're no longer parallel with the base, now I'm going to get the oval. Okay, I can move that up or down, and that's going to just change the size of the oval or the ellipse. If I increase this some more, now the plane is intersecting the cone as well as the base of the cone. That's when we're going to get a parabola. And then if I make it so we're intersecting both halves of the cone, that's where we get a hyperbola. A hyperbola has 2 curves to it. Each one looks like a parabola. The properties of the hyperbola are not quite the same as a parabola. We'll learn when we get to these that you have 2 asymptotes, 2 what we call oblique asymptotes associated with the graph. Okay? All right, so today we're focusing on the circles first and foremost. These are the ones you should probably have experience with already from geometry, right? Definitions are really important in this unit, okay? So the definition of a circle is given there at the top. It's a collection of points that are all equidistant from a fixed point called your center. And we know the distance that we have between each of these points and the center is known as the radius of the circle, right? Okay, so based on that definition, if we look at the circle that I have pictured here that's centered at the origin, if I just pick a random point on the circle and we just label it xy, I can use my distance formula to come up with the equation of a circle. So normally we say distance is square root of x sub 2 minus x sub 1 added with y sub 2 minus y sub 1 squared, right? Well, in this case, we're calling the distance r for the radius. And then x sub 2 minus x sub 1, if we're using the points x, y, and 0, 0, would be x minus 0 squared. And then on the other half, we'll get y minus 0 squared. R squared would equal the square root, or I'm sorry, r would equal, getting ahead of myself, the square root of x squared plus y squared. And then if we square both sides, that's going to lead me to, and I'm going to reverse this. I'm going to say x squared plus y squared equals r squared. Does that look familiar? That is the equation of a circle centered at the origin with a radius of r. Okay, now many of you have taken trig or are currently in trig. You work with the unit circle in that course, right? Unit circle is centered at the origin and has a radius of 1. So we should know that equation is x squared plus y squared equals 1, right? Very useful for helping us to evaluate trig functions at angle measures of like 30 degrees, 45, 60, etc. Okay. All right, now if we move to the next page, what if we want to shift the center of the circle away from the origin? Let's say we want to shift it to the point HK. Well, what is that going to do to my equation? I use the distance formula again. The distance, which we'll call r, would now be the square root of x minus h squared plus y minus k squared. Square both sides. And we'll end up with, let's reverse it, x minus h squared plus y minus k squared equals r squared. So this is the equation of a circle centered at HK with a radius of r. I refer to that commonly as the standard form of the equation of a circle. Our textbook calls that the center radius form. Center radius form. All right, so write the standard or center radius form of the equation of a circle whose radius is 4, centered at 2, negative 6. So obviously 4 is r, 2 is h, negative 6 is k. Just substituting those into the equation above. X minus 2 squared plus y minus negative 6 squared equals 4 squared. And of course we can simplify that to x minus 2 squared added with y plus 6 squared equals 16. All right, now, what if we want to graph something that's in this form? Really simple. Just by looking at that equation, what are the coordinates of the center of this circle? Good. 1, negative 3. What's the radius? Square root of 16 or 4. So we're going to plot 1, negative 3. And then from that point, we're going to move 4 right, 4 up, 4 left, 4 down. Okay, now you could draw it by freehand. I'm going to use the shape tool here. I'm going to choose a circle. I'm going to format it so it has no fill. I'm going to change it so it has a border, increase the width of the border, maybe change it to the color blue for Revere. Shrink it down to size. Let's go. Questions there? Okay, now there's a whole nother form for the equation of a circle that we're going to see on the next page. Okay, suppose I take this center radius or standard form and I remove the parentheses. Basically what I mean by that is let's square the binomials. So if I do that, I'll end up with x squared plus 4x plus 4 added with y squared minus 6y plus 9 equals 9. And then I'm going to rearrange my terms. X squared plus y squared. So I put the two squared terms or quadratic terms first. plus 4x minus 6y, so the two linear terms next. And then I combine my constants. Well, these cancel out, so I'm only left with a 4, and then we're going to say equals 0. Okay. This is known as the general form of the equation of a circle, and we will find in some later examples where this can be useful for us. Okay. All right, now the one thing the general form is really not great for sure, is graphing. So here this equation starts in the general form. To graph it, we got to put it back in the center, radius, or standard form. That's going to require us to do some completing the square, okay? So what I'm going to do is group together my two terms that have x in them, along with a plus blank that I'll use for completing the square. And then I'll do the same with the terms that have y in them. There's the constant of negative 12. I'm going to add it to the other side. Okay? And think, if I'm going to add two numbers in to complete the square, I have to nullify those by adding those numbers on the other side of the equation. Okay? All right, so what number would complete the square on x? What value would I add in after the x squared minus 6x? What do you think? 9. Yeah, we take half of negative 6, which is negative 3, square it to get 9. And we're going to add 9 to the other side as well to maintain equality. Okay, for the y's, half of 4, 2 squared is 4. So we're going to add 4 to both sides. That now allows us to factor to x minus 3 squared added with y plus 2 squared equals 25. Now we can easily identify center is 3, negative 2, radius square root of 25 or 5. And then we can proceed just like the previous example. 3, negative 2, go 5 right, 5 up, 5 left, 5 down. Grab a circle, no fill. Give me a border, increase the border, change it to, let's go red this time for Revere. Shrink it down. Question so far? All right, next example. Find the coordinates of the points where the line y equals 2x minus 2 and x squared plus y squared equal 25 intersect. So let's graph these first. X squared plus y squared equals 25 is centered at the origin. Radius would be 5. Grab a circle again. Make that a little bigger. There we go. Okay, so that I did in blue. I'm going to do the line in green. Now that's slope-intercept form. Y-intercept's negative 2. Slope is 2, or 2 over 1. So up 2, right 1, repeatedly. Or down 2, left 1. All right, and from this, we can see there's two intersection points, right there and right there. Now, the one that's in quadrant 1 looks to be exactly 3, 4. The one, though, that's in quadrant 3 does not appear that that's a lattice point with integer coordinates. So let's do some algebra here to come up with the coordinates of these, all right? I'm just going to solve this. It's a system of equations, right? So I'm going to solve this by substitution. I'm going to replace y in the circle equation with 2x minus 2. And then I'm going to solve this for x. X squared plus, that would be 4x squared minus 8x plus 4 equals 25. That's 5x squared minus 8x minus 21 equals 0. And that is factorable. Five x plus 7, x minus 3 equals 0. So x is negative 7/5 or positive 3. And then I will substitute each of those in for in for x in my linear equation. So 2 times negative 7/5 plus 2. That's going to be negative 14/5. How about plus, actually this is a minus, sorry. So then it's minus 10/5 for a common denominator. So that's negative 24/5. If I make x 3, I end up with y equals 4. So my intersection points negative 7/5, negative 24/5, and 3/4. Which, checking the graph at those two red intersection points, those seem pretty valid. Questions there? All right, example 5. Here's where it starts to get real fun. Okay, find the equation of a circle containing points 0, 11, 0, negative 13, negative 7, 4. These are not anything special. None of these are the center of the circle. I'm not told about the radius of the circle. These are just 3 random points on the circle. This is where the general form is really helpful. I'm going to take each of these points and plug them into the general form. And what it's going to create is a 3x3 system of equations. So I'm going to do the first one in blue here. I'll make x 0, y is 11. And I'm going to simplify that here in a moment. Pick a different color for the second point, do the same thing. Make x 0, y is now negative 13. And then pick one more color for the third and final point. So here x is negative 7, y is 4. All right, so now I'm going to simplify each of those as best as I can. The blue equation will become 121 plus 11b plus c equals 0. The red equation will become 169 minus 13b plus c equals 0. In the green equation, you'll get a 49 plus a 16. That's a 65 minus 7b, minus 7a, plus 4b plus c equals 0. And here is our 3x3 system that we have to solve. Okay, first step to solve, I'm going to take the blue and the red equations. And I'm going to eliminate C. To do that, I would use subtraction. So that's going to give me negative 48 plus 24b equals 0. That means 24b will equal 48, making b 2. All right, next step, I'll take that b equals 2, I'll plug it back into the blue equation. That way I can solve for C. 121 plus 22, that's 143, added with C equals 0. That means C is negative 143. And now that I have both B and C, I can use the green equation to get my A value. 65 minus 7A plus 4 times 2 minus 143 for C equals 0. That's going to be negative 7A, minus 70 equals 0. Negative 7A equals 70. A is negative 10. Now I can form the general form of this circle equation. X squared plus y squared minus 10x plus 2y minus 143 equals 0. So there's your general form, and then of course we could complete the square on this to put it in the standard or center radius form if we were asked to. Questions there? All right. Final example. Find the equation of the line tangent to the circle at the point 3,5. Let's put it in to the other form first.
You said your attendance.
I don't have access to that because I'm the fill-in today.
Is anyone absent?
Is anyone absent? No? Okay, thank you.
Okay. Yeah.
All right, sorry, I'm kind of rushing here to get this finished. All right, so I only have to complete the square on x in this case because there's only the squared term with y. There's no linear term. Okay? Half of 4 is 2. 2 squared is 4. So I'm going to add 4 to both sides. This would be x plus 2 squared added with y squared equals 50. So your center is negative 2, 0. Your radius is the square root of 50, which we could, of course, say is 5 radical 2. All right, so you plot your center, and we go square root of 50, which is just over 7 units, left, right, up, down. Okay, now we want to be tangent to the point 3,5, which if you look right there is the point 3,5. It is on the circle. Okay, so think a tangent line should be a line that touches the circle at that point and only that point, right? Well, recall maybe from geometry you have a property that the radius of the circle is perpendicular to the tangent line, yes? What do we know about slopes of perpendicular lines? They're opposite reciprocals, right? So the slope of the yellow radius that I just drew in there, you're going up 5, right 5. The slope of that is 5 over 5, or 1. So what's the slope of the perpendicular tangent line need to be? -1. Okay, so now I got everything I need to build this equation. I'm going to use point slope form. Maybe recall this from algebra 2. I'll use the point of tangency. Its y value is 5. Just said the slope should be -1. And the x value is 3, right? So this is y minus 5 equals -x plus 3, or y equals -x plus 8. There it is. Okay, now if I didn't draw my tangent line the best there, but should be crossing the y-axis at +8 if I was a little neater. Any questions?